We are back at week 13, set 2, SWYK 2. Same old scenario with our first question. Set each one of the factors equal to 0 and solve them. And we get negative 3, 4, and 6. Same old broken record on that question. Hey, I'm going to slide myself out of the way just a little bit here. Actually, probably better over here somewhere. Now, don't you slide that over. Pause for... All right, folks, on this next question, sorry for the interruption here. I needed to move my face out of the way. We want to look at this graph and answer the following questions about things called increasing and decreasing intervals. Keep in mind that increasing and decreasing intervals, these things are intervals about x values. All right? Now, in order to do this, we need to know where our relative maxes and relative minimums are. Now you can tell on this graph that there is no highest y value. Now keep that in mind. That's another important point that I circled over here. Relative maxes and mins are y values. Same thing with what we call absolute maxes and mins. Now remember that an absolute max and min would be the highest or lowest point y value on the entire graph. But you can tell this thing goes as high as you could ever want it to go, because it never stops, right? Same thing up here and same thing down there. It never, keeps going down. So there is no absolute max or min. So when we use these terms like relative max or min, we're saying to ourselves, hey, there's a neighborhood, right? And inside that neighborhood, I know that's a technical math term, but they actually use that term neighborhood. Inside that little neighborhood, there is a highest point. Or inside this neighborhood, there's a lowest point. In other words, we're looking for little hills and valleys. That's what we're really after, okay? And then inside that, since we can claim that there's a max or a min inside that little neighborhood, we call it a relative max or a relative min. Sometimes the word local is used. I've seen that in different textbooks. Anyway, so we want to know what these relative maxes and mins are. I think it looks this picture looks a little bit too busy, so maybe I should erase just a touch of it. Let me pause. So in this discussion about increasing and decreasing, we're going to be moving through the graph from left to right. And imagine it's kind of like a roller coaster, right? You're going to go up, you're going to go down. If you're moving from left to the right through this graph, you can see that between here and here, we are moving up. That's called an increasing section of the graph. So how would you describe that? Well, I'm going to scroll up here just a little bit because you can see that the first multiple choice answer, there's only 2 answer choices, and it says, what do you think's happening from negative infinity to negative 0.535? Those are x values only. That's the description. These are x values. Okay? Now, the words you are using, increasing or decreasing, describe the y values, right? These terms describe the y values. So do you think the y values are going up or going down? Remember that we continue to go through the graph from smallest numbers, smallest x values to largest x values. We can see that we're going uphill on the roller coaster, so it'd be increasing. Well, what happens when you go from this section right here, negative 0.535, all the way over to 1.869? We can clearly see that we're going down the roller coaster. So in that particular section, from negative 0.1535 to 1.869, we are decreasing. Well, what do you think's happening? Maybe I can, oops, that's not what I wanted. Maybe I can shrink this down a little bit so I can get more of the question, even though it's a little bit too small. So what do you think's happening from 1.869 to infinity? So that would be this section of the graph, from this here to there. Well, it looks like we're going up and up and up and up and up. And that's exactly right. We are increasing. So in these particular situations, and by the way, if I ever ask you for a relative max, I am asking for the y value only at the top of that little hill, or relative min, the y value only at the bottom of that little valley. Speaking of relative maxes, this graph has a relative max of 8.209. This one has a relative min of negative 4.061. So those are the relative maxes. You can see that we have split the graph up into sections. We've got from negative infinity to negative 1.21, from negative 1.21 to 1.786, and from 1.786 to infinity. We're asking about the increasing and decreasing. So in the first section, we're definitely coming down the roller coaster. And in the next section, we're definitely going up the roller coaster. And in the last section, definitely back down again. Okay? So it's not terribly confusing. We just want you to understand how it's getting split up. You do need to know what the relative maxes and mins are. Now, in question 4 here, we're splitting the graph up, right? We've got a relative max here at 0. We've got a relative max here at 32. And we've got a relative min here at negative 4.395. It's at the tops of the hills and the bottoms of the valleys. Okay? And so what's going on? We split it up from negative infinity to negative 2. In that section, it looks like we are going up, increasing. But then from negative 2 to negative 0.75, in this section right here, back to going down, right? What about from negative 0.75 to positive 2? Going back up again, right? So that's the next question. And then lastly, from negative 2 to infinity, we are decreasing again. So those are the answers to those particular questions on question 4. Increasing, decreasing. What if we split the graph up a different way? What if, instead of using relative maxes and mins, what if we split a graph up based upon their x-intercepts? Here this graph has an x-intercept at negative 2, at 0, and 3, right? And so we can talk about intervals based upon positive and negative. Obviously, positive goes above the x-axis, negative goes below the x-axis. So what do you think about the description of everything from negative 2 all the way, or negative infinity to negative 2? That section of the graph looks like it's in the positive section, right? And so that's why we labeled it that. From negative infinity to negative 2, we called it positive. Well, what about from negative 2 to 0? Well, that section looks like it's below the x-axis, so that would be a negative section, right? How about from 0 to 3? 0 to 3, back to the positive section. You are right. And then from 3 to infinity, we are back to the negative section. From 3 to infinity, back to the negative. Now, don't get it in this. I know that in a lot of these situations so far, you've seen it looks like it's going back and forth, alternating. It can. It doesn't mean it has to. I'm going to show you an example here in a little bit. Might not be the next one, but it's definitely coming to a theater near you. Okay, let's take a look at this one, right? So everything from negative infinity up to negative 1. All of that looks like it's on the negative side. So that's why we marked that negative. How about from negative 1 to 0? Well, all of that looks like it's above the x-axis, so that would be positive. From 0 to 3, that all looks like it's below, so that's negative. And from 3 on to infinity, all of that looks positive to me. So all of that's in the positive realm. Okay, let's take a look at another example here. Okay, in this last example, what we're looking at here is from negative infinity to negative 3. So everything from negative infinity up to negative 3. All that looks positive, so it's above, right? And then from negative 3 over here to positive 1, all of that looks negative, all right? All that makes sense. But then right here, when we go from 1 to 4, it doesn't go above the x-axis. That's because of that whole bounce situation that's going on. It stays in the negative. So you can't just trust that it's going to go back and forth all the time. You have to pay attention to the graph and see what's going on. And then from 4 to infinity, we're back in the positive realm, right? 4 to infinity, all above the x-axis, so that's why it's positive. Okay, and so that's that particular complete problem right there. And I believe that's the last one for this one. Yep. So just wanted you to be aware, you can't always trust it's going to go back and forth. A lot of times it does, but it doesn't mean it always will. So please make sure you're aware of that. And I think that's it for this particular SWYK. you're done with SWYKs. You got to get to that assignment and then on to your test. Have a great day.